frequencies and it will reject the higher frequencies. Suppose I say this is the cutoff frequency omega naught. So it will pass this frequency. So this is your pass band. And after this it will reject. So this is called a stop band. So this is an ideal low pass filter. This is not possible in practical that we can get this sharp cutoff. जैसे इतना मतलब omega naught से 0 हो जाएगा. So the practical filter is like this. That means the gain is not constant for the pass band. It will be constant for some time and then it decreases and goes to 0. So the frequency at which the gain is, this is gain A, the gain is 1 by root 2 times of gain A is called as cutoff frequency. So this is your cutoff frequency. And then this is your stop band frequency. This is called as transition band. Okay, so this is your low pass filter. Let me draw the high pass filter. High pass filter, it will pass the higher frequencies and it will reject the lower frequencies. Again, I can say this is VO by VI and this is frequency. So lower frequencies it is rejecting and the higher frequency it is passing. So this is your high pass filter. Now this is an ideal filter. So when I say practical filter, so practical will be like this. So this is the gain A. If this is the gain A, if I say that this is A by root 2, so that is cutoff frequency. We can call this as FL. This is FH, FL. Is it clear what I am drawing here? The frequency response of the filters. Any doubts in this?
No, ma'am.
Yes. Next is band pass filter. So band pass filter.
Ma'am, what is
It passes the band of A by root 2 is, we say here the 3 dB bandwidth. I'll tell you about 3 dB bandwidth. I'll tell you where the power is half of the A by root 2. Yes.
How you are calculating that FH
Yes.
and FL? How you know the position of FH and FL?
I'm not calculating. I'm not calculating. I'm telling the frequency at which the gain is A by root 2. Now what is A by root 2? What is A by root 2? Tell me when the gain is 1 by root 2 times of the maximum gain. What is the power? Can anyone tell me what will be the power? Yes. I'm saying A by root 2. So when gain is A by root 2, that means your gain is A by root 2 times. What will be power in gain? That is your VO by VI is A by root 2. Can you tell me, anyone can tell me the formula of power? What is power?
V is equal to
जल्दी
VI.
में पढ़ा है VI और ओनली V के फॉर्म में मुझे चाहिए पावर का फॉर्मूला. हाँ,
I square R.
V square by R, I square R और V square by R, right?
Yes, ma'am.
Yes.
हाँ, तो अगर मैंने बोला VO by VI is A by root 2, what will be power here? Power will be VO square by VI square power ratio, and that will be A by 2, right? Right? No? Yes or no? Batao.
Yes, ma'am.
Yes. So why we are doing A by root 2? Because A by root 2 is the voltage gain and the power ratio is A by 2. Okay, and A by root 2. That's why we can call it as A by root 2. That A by root 2 we are naming it as a cutoff frequency. By this why we are calling it as cutoff frequency? Because this is also called as 3 dB bandwidth. You calculate here what is the log of A by 1 by root 2. Yes, can anyone tell me the log of 1 by root 2?
Ma'am, log of 1 by root 2 is minus 0.1505.
What is the, see, what I am asking is 3 dB जैसे कैसे आया? So what is a by root 2 if I find in dB? So I want 10 log of 1 by root 2 times, that is a by root. कितना आएगा 20 log of a by 1 by root 2? Can anyone tell me? What is 20 log of 1 by root 2?
Ma'am, minus
minus
3.01. Yeah, ma'am.
So that is what, when your gain is 3 dB down. And when the gain is 3 dB down, we call it as cutoff frequency. So this is the cutoff frequency for a low pass filter. मतलब क्या होगा कि fh तक, when we say what is fh is the frequency at which the gain will be 1 by root 2 times of the maximum gain. Similarly here fl is the gain, where fl is the frequency of a high pass filter, cutoff frequency of a high pass filter, at which the gain is 1 by root 2 times of the maximum gain. After that you are getting the pass, means after this the frequencies are passing after this frequency. This is called as cutoff frequency. एंड इसका नाम 3 dB बैंडविड्थ भी बोलते हैं. इसको हम हाफ पावर बैंडविड्थ भी बोलते हैं क्योंकि पावर इज हाफ पावर बैंडविड्थ, और वी कॉल आल्सो कट ऑफ फ्रीक्वेंसी. एंड हाफ पावर क्यों बोलते हैं? क्योंकि रेशियो ऑफ पावर इज हाफ एंड रेशियो ऑफ वोल्टेज इज 1 by root 2. 3 dB bandwidth because when we find in dB it is 3 dB. 3 dB down the maximum gain. मतलब अगर यहाँ पे 20 dB होगा तो a by root 2 पे 20 minus 3 17 dB होगा. Okay.
Yes, ma'am.
Yes. Now I'll go ahead. Let us see the band pass filter. So this is the band pass filter.
ये जूनियर का अटेंडेंस निकलना भी तो मुश्किल है क्योंकि इलेक्टिव वालों का प्रॉब्लम है वहाँ पर.
तो फिर इलेक्टिव वालों को अलग से निकालने बोलो, बाकी लोगों को
मैं एक्स्ट्रा भी शेयर कर सकते हैं.
नहीं बोला, नहीं है ऐसा. हो रहा है कि जो स्लॉट में अटेंडेंस वालों को निकालो, इलेक्टिव वालों का बाद में देखते हैं. Yes, band pass filter is band of frequency. So this is the pass band and this is stop band. This is also stop band. Yes. Now this is an ideal filter. Let us draw the practical filter. So you can tell this is a combination of a low pass filter and a high pass filter. Low pass and high pass. You see the right hand side. Right hand side is a low pass filter and left hand side is a high pass filter. So this frequency, we can say this frequency at which the gain is suppose 1 by root 2, we can call this one. इसको ही बोले अगर suppose we are just saying that this is the frequency. Suppose this is the frequency. So what is this frequency? When we say it is 1 by root 2, it is called as, this is a high pass filter. So this is your FL and this is your FH. If we say that the gain is 1 by root 2 at this point, for this sake. So this is called as bandwidth. FL minus FH minus FL is called as bandwidth. This is a band pass filter. Right? Now let us make the high pass filter. Sorry, band reject filter. It is just opposite of the band pass. You have like this. It rejects the band in between. So we can say this is your pass band and this is also pass band. This is stop band. Let us draw the practical. So this is again the combination of low pass and high pass, but in different way. पहले low pass है and then high pass. Now this is a high pass and this is the low pass. Is it clear? All type of filters? You have just drawn the gain. So this is your analog filters. When we are calling, this is nothing but analog. Digital filters नहीं बोल रहे इसको, analog filters. Because we are showing f, this is f, and we are showing up to infinity. Digital filters में infinity तक नहीं रहता है. We have some periodic range. वो बाद में देखोगे. These are all analog filters. Any doubts in this? Yes. यस बताओ कुछ डाउट्स है इसमें. फिल्टर का मतलब क्या है? अगर मैं लो पास फिल्टर बोलती हूँ and एक साइलैब में I'll show you the implementation simulation कि if I say that we want to design a filter of 100 hertz, so that means 100 hertz is the cutoff frequency. Cutoff frequency means वहाँ पे आके your gain will be 1 by root 2 times of the maximum gain, right? So what will happen when I give the input to that filter? The inputs 0 to 100 hertz will be passed in low pass filter. और 100 हर्ट्ज आते आते जैसे जैसे मैं क्लोजर जाऊंगी 100 हर्ट्ज के, माई गेन विल डिक्रीज. ए बाय 1 बाय रूट 2 हो जाएगा हर्ट्ज पे, और 100 हर्ट्ज के आगे वो और ज्यादा डिक्रीज होगा एंड फास्टली डिक्रीज होगा. यू कैन सी 100 हर्ट्ज के बाद वो फास्टली डिक्रीज होगा, नीचे जीरो पे जाएगा. देन इफ यू गिव सम 1000 हर्ट्ज और 2000 और 5000 हर्ट्ज, इट विल गिव यू ऑलमोस्ट दी जीरो गेन. इज इट क्लियर? So can I go ahead?
Yes, ma'am.
Yes, ma'am.
Yes. So now this is, I'll come to the roll off rates. Roll off rates in low pass filter. That is very helpful. You'll understand. So when I say low pass filter, अभी मैं low pass filter के बारे में बात कर रही हूँ. Only low pass. So when we plot in dB, this is my gain, I say, and then we have dB में है तो we have slope. So when I'm saying we have decade का roll off, we can say a slope. We can have minus 40 dB per decade का slope, and we can have minus 60 dB per decade का slope. Like this we can go by 20, minus 80 dB per decade का slope, like this. Because you know that filter में जब भी हम terms लेंगे तो it will be coming something like this, 1 by s or 1 by s plus 1 or 1 upon s plus 1 square, ऐसा आएगा. फिल्टर लो पास फिल्टर में हमेशा एस डिनोमिनेटर में आता है. -20 dB, तो मतलब अगर यहाँ पे हमारा फ्रीक्वेंसी ओमेगा है तो 10 ओमेगा पे जाके इट विल बी -20 dB लेस देन whatever gain. Suppose this is A, this will be A -20. So we'll call this as, this one as -20 dB per decade slope. Right? If I say -40 dB, जैसे ये वाला मैंने प्लॉट किया, -40 means it will decay by 40 dB in 10 times, means 10 omega and 10 omega. तो A है तो यहाँ पे suppose I'll just draw this. Suppose this is A -40. Okay, तो क्या होगा, यहाँ पे आएगा ये point. So what you'll do, 40 dB decade जब बनाना है तो you will join these two, because what will happen when omega will change by 10 times, your gain should come 40 dB. So this is your, this slope is -40 dB per decade, right? Then suppose this is your E -60. Here this will come by 60 dB. So this is your 60 dB per decade. So by seeing the slope, you can tell me that what is the denominator of this low pass filter. ये -20 dB है तो तुम लोग बोलोगे एक ही s फैक्टर है डिनोमिनेटर में. -40 dB है तो दो s फैक्टर्स है, because s square, and when you take -20 log of s square, it will become -40 log of s. That will give you -40 dB per decade. तो इफ आई एम जस्ट, अगर तुम सिर्फ ऊपर का पार्ट देखते हो ऐसा, दीज आर द थ्री स्लोप लाइन्स, 1 2 and 3. 1 is your minus 20 dB, 2 is your minus 40 dB and 3 is minus 60. और जाएंगे तो ऐसा आएगा, और जाएंगे तो ऐसा आएगा. What I am going to tell you, tell me, क्यों मैं ऐसा बता रही हूँ? मैंने minus 20 dB बोला तो स्लोप ऐसा है and this is a practical amplifier. जैसा जैसा मैं स्लोप बढ़ा रही हूँ वो कैसा आ रहा है, वो आइडियल के पास में आ रहा है. What it tells that when we increase the order of the filter, we are going closer to the ideal filter. Ideal filter कैसा है लो पास? Just ये this one is your ideal filter. And practical filter मैंने कैसे दिखाया कि depending on the order of the filter you will get. So this one is minus 20 dB single. और जैसे जैसा हम लोग उसका slope बढ़ा रहे हैं, we are moving to the ideal filter. Any doubts in this?
No, ma'am.
So this is just to show you कि जब हमारे पास डायग्राम रहेगा frequency response का, from there also we can get the order of the filter, or when we have the order of the filter we can draw the response. Okay, so this is about the roll off rates in low pass filter. Yes, so I have told you about active filter, what are passive filters, what are active filters, and type of filters, that is low pass, high pass and band pass and band reject. Let us see active filter which we have in this syllabus. What are active filters? I told you yesterday. I defined it. I given the
A
definition.
filter which uses op-amp and all with capacitor resistor.
Yes, right. So we are going to see the active filter using op-amp. So the filter which uses op-amp. Why it is called as active? Because op-amp has voltage source. We are giving a power supply to the op-amp, right? That's why it is an active filter. So we have seen that when the order of the filter increases, यहाँ पे देख लो, मैं बाद में फिर से दिखाऊंगी कि जब हम order करते हैं तो we are moving to the practical filter. Okay? Yes. So active filter is using op-amp. I'm drawing that now. एक filter है just. This is your R and C. Is this an active or passive filter?
Passive filter because
Passive.
R and C.
Just find output by input. Can anyone tell me output by input of this? This is a passive filter. This is a passive filter. There is no supply. Yes. What is VO by VI? Yes. What is VO by VI for this? What will write for C here? Yes, I'll write CS 1 by SC. So VO by VI when I do is nothing but the voltage division rule. Can anyone tell me what is VO by VI? What is VO by VI? Can I apply the voltage division rule?
Yes, ma'am.
Yes, then tell me the answer. क्या आएगा?
1 by CS upon R plus 1 upon CS.
Yes, right. 1 upon SC upon R plus 1 upon SC. So when I simplify it, it is SC upon, नहीं SC नहीं आएगा, 1 upon SRC plus 1. What is the order of the filter? Can anyone tell me?
1.
Is it a low pass filter or a high pass filter? Is this a low pass or a high pass filter? नहीं आता है, बोलो नहीं समझ में आया. I will tell. Can you tell me whether it's a low pass or a high pass filter? Yes. No, no.
No, ma'am.
How to see
Okay.
that? whether it is low.
Yes, yes, I'll tell you now. VO by VI is a low pass or high pass filter, so we have to see the relation with the frequency. अभी मैं अगर relation with frequency बता दूँ तो तुमको मालूम पड़ जाएगा. What is frequency here? S. S is what? J omega. So I've written the value of S as J omega. Now what is the magnitude of this? You know how to find the magnitude of this? Yes, 1 upon RC root of omega square plus 1 by RC square, right?
Yes, ma'am.
Right? Right or no?
Yes, ma'am.
I am.
Yes. Okay. I want to see whether it's a low pass or high pass. बहुत important है देखो. So I say when omega is very small value, very small, very small. So what you can do? Very small than 1 by RC. What
Neglected.
Neglected.
can I do? Can I neglect omega? Yes. Then what?
Yeah.
Neglect it. Then what will be VO by VI?
1.
Yes. Now I tell that omega is much greater than 1 by RC. Then what you will tell? What I can neglect?
1 upon RC.
1 by RC.
I can neglect 1 by RC and I can say that my gain is 1 by omega RC. Right?
Yes, ma'am.
J को हटा दिया 1 by omega RC. Now can you tell me it's a low pass or high pass filter? When omega is much less than 1 by RC, your gain is 1. And then when omega is some much greater than 1 by RC, your VO by VI is inversely proportional to omega. Can we plot the frequency response?
Yes, ma'am.
Suppose this is your 1 by RC. 1 by RC. Suppose this is your omega equals to 1 by RC. Yeah. Tell me. Gain is 1. Gain is 1 up to 1 by RC. And then after 1 by RC, when my omega is increasing, my gain is decreasing. Then I can do like this.
Yes, ma'am.
What is it now? Tell me low pass or high pass filter?
Low pass.
It's a low pass filter. Also, I'll tell you one more way to do. You see now. Capacitor is on this spot. तुमको ये सब आता है करना. When omega is 0, that means when omega is very less, smaller frequencies. Smaller frequencies. What is 1 by omega C? Higher value. Right?
Yes.
Higher value, that means the input will be same as output. इधर नहीं जाएगा ना वो. इधर नहीं जाएगा, bypass नहीं होगा. It will directly go here. But when omega is very high, what will happen? 1 by omega will become 0. It will go like this. It will not go out. That means it is stopping the higher frequencies. It's a low pass filter. अगर तुम सर्किट डायग्राम देख के भी समझ सकते हो एंड बाय ट्रांसफर फंक्शन ऑल्सो. इज इट क्लियर? जब भी ऐसा सर्किट होगा तुमको पैरेलल में कैपेसिटर है यहाँ पे आउटपुट में, इट्स अ लो पास फिल्टर. उल्टा करेंगे हम, कैपेसिटर और आर, इट्स अ हाई पास फिल्टर. इज इट क्लियर? यू कैन एनालाइज इन एनी वे, but I'm just telling you this RC because I'm going to introduce this RC in op-amp now. So are you convinced that it's a low pass filter?
Ma'am, could you please repeat how you got that in the circuit by seeing the circuit only?
Yeah, see, this is R and this is C. Is it 1 by omega C?
Yes, ma'am.
Yes. When omega equals to very small, that means lower frequencies. When omega is very small, what is 1 by omega C?
It is high.
High. तो जब यहाँ पे करंट आता है तुम्हारा, तो वो कहाँ जाता है? हाई वैल्यू पे.
Where it is low.
Yeah. So that is high. 1 by omega C is high. जहाँ पे रेजिस्टेंस कम होता है वहाँ पे करंट कम आके यहाँ पे जाता जाएगा. That means if I say I1 and this is I2, I2 will be more than I1.
Yes.
Right?
Yes, ma'am.
क्योंकि तुम्हारा ये इम्पिडेंस ज्यादा है, वहां पे उतना करंट नहीं आएगा. राइट? व्हेन ओमेगा इज लार्ज, When omega is large, what is 1 by omega c? Small. And when 1 by omega c is small, पूरा करंट उधर आ जाएगा. It will be like short. पूरा करंट उधर आ जाएगा, मतलब ये ब्लॉक हो जाएगा, आउट बाहर जाएगा ही नहीं आउटपुट पे. So we can say that when omega is small, the signal is passing from input to output, but when omega is large, the signal is not passing from input to output. It's a low pass filter. Is that clear?
Yes, ma'am.
Yes. So I just remember that जब भी ऐसा सर्किट आया, ऐसा, this is the low pass filter of first order. This is first order low pass filter. अगर मैंने 2 लगा दिए कास्केड में, this is your second order low pass filter. Low pass filter. उल्टा किया हमने उसका. C and R, and then again C and R. This is your second.
High pass filter.
Clear?
Yes,
Yes,
ma'am.
ma'am.
Yes. Now I am going to the first order active low pass filter, जो तुम्हारे सिलेबस में है. अभी तुमको फिल्टर थोड़ा क्लियर हुआ है. फर्स्ट ऑर्डर एक्टिव लो पास फिल्टर, ये पैसिव पढ़ा आपने. सो एक्टिव में हमारा ऑप-एम्प आ जाएगा. ओके, देन यू हैव 2 resistors RF and R1. We'll ground this. And then you have an RC component. What is this? This is a filter, low pass filter, but उसके साथ हमने op-amp लगा दिया. This is your VI and this is your V1. V1. Now we have to find V0 by VI. ये देख के ही समझ गया ये फिल्टर है. क्यों? क्योंकि उसमें RC कंपोनेंट है. Let us find out the VO by VI. Is it a inverting or non-inverting amplifier?
Non-inverting amplifier.
Non-inverting. Okay. Let us find the gain of this. किसी को कुछ डाउट है? Yes, anyone?
No, ma'am.
Okay. So we'll start with now the gain. Yeah. So what is non-inverting? VO by V1. VO by V1, because V1 यहाँ पे जो नॉन इन्वर्टिंग में कैसे करते हैं, जो यहाँ पे वोल्टेज है उससे हम गेन निकालते हैं, राइट. तो व्हाट इज VO by V1 इज 1 प्लस RF अपॉन R1, राइट.
Yes, ma'am.
यस. नाउ वी हैव टू फाइंड VO by VI. उसके लिए हमको V1 निकालना पड़ेगा. तो अभी अभी हमने निकाला था RC का. व्हाट इज V1 अपॉन VI? What is V1 upon VI? You have to apply the voltage division rule. अभी हमने निकाला था 1 upon SC upon R plus 1 upon SC. V1 by VI. So this is your equation number 1 and this is number 2. Number 2 को हम लोग वापस लिखते हैं. V1 by VI, V1 upon VI equals to on SCR plus 1. Right? Now, putting this 2 in 1. So what will be if you substitute value of V1 in equation number 1? What you'll get? VO by VI equals to, दोनों को मल्टीप्लाई करेंगे तो भी आ जाएगा. Multiply 1 and 2 you'll get, right? What is this? 1 plus RF upon R1, 1 upon SCR plus 1. Okay?
Yes, ma'am.
Yes. Now, this is your VO by VI. And you can see whenever you have S component in the denominator, अभी हमने देखा it's a low pass filter. Now, let us see what is VO by VI finally. So this is 1 plus RF upon R1 upon SCR plus 1. Right? Now, this I'll write this as 1 plus RF upon R1 is the gain. इसको अगर हम ऐसा लिखें upon or j omega upon omega h, because we want the cutoff frequency. S is your j omega और उसके divided by omega h is your cutoff frequency. So what is omega h from here? 1 by RC. And it is nothing but 2 pi into fh equals to 1 by RC, or fh equals to 1 by 2 pi RC. Right? इतना समझा?
Yes, ma'am.
Yes, ma'am.
Yes. Now from this only I'll tell you that हमने बोला it's a low pass filter. Let us see. When f is less than, when f is very much less than fh, capital H, fh. When f is very much less than fh, what will happen? We know that V naught upon Vi, when f is very much less than fh, it is V naught upon Vi is just 1 upon Rf. ये जल्दी समझेगा अभी, क्योंकि मैंने बताया कि f is less than fh, we can neglect this term. We have just 1 plus Rf upon R1. When f is greater than fh, when f is greater than fh, V naught by Vi equals to 1 plus Rf upon R1 upon क्या आएगा? f upon fh. Right? And when I say that f is equal to infinity, then your V will become 0. This shows that when frequency is increasing, your gain is becoming 0. Now, I'll take as when f equals to fh. When f is equals to V naught by Vi equals to 1 plus Rf upon R1 upon f is equals to fh, so it will become j plus 1. क्योंकि f is equals to fh, so that will become 1 plus j. So if I find VO by Vi magnitude, what will be the magnitude? Tell me what is the magnitude of 1 plus j? It is just root 2. So this is, I told you the gain, यहाँ पे gain क्या है 0 पे, जब starting gain is 1 plus Rf by R1. If this I name as A naught, this I name as A naught, this is A naught F by FH. Gain निकाल रहे हैं हम सिर्फ. So I can say that this is A naught by root 2. So when f is equals to fh is called as A by root 2. This is also called as 3 dB frequency or cutoff frequency. और bandwidth of the filter. बहुत सारे नाम है. Yes, any doubt?
मैम और एक बार एक्सप्लेन करोगे?
I'll explain you again. One second. See what we have done. Same जैसे हमने RC का लिया था ना, वैसे ही हमने op-amp के साथ RC लगा दिया. ऐसा ये सर्किट डायग्राम है. Yeah. So V naught by V1 निकाला हमने पहले. क्यों? Because non-inverting amplifier का gain is at this terminal. So V naught by V1 is 1 plus Rf by R1. Thus we can call it as gain of non-inverting amplifier. Then what is V1? हमने यहाँ पे voltage division rule लगाया. V1 1 upon SC अपॉन आर प्लस वन बाई एस सी। इसको सिंप्लीफाई किया तो V1 by VI is 1 upon SCR plus 1. Then you multiply these two equations because we want VO by VI. तो V1 cancel हो जाएगा when we multiply. And in the right hand side you have 1 plus RF upon R1 into 1 upon SCR plus 1. So you can see here we are getting only one S component in the denominator. And when we have the first order, this is nothing but first order filter. So we know that the this S component, one S component is there, so it is a first. Write in this way VO by VI. And if you want to write in terms of frequency, what is S? S is J omega. So बाकी जो component है उसको divide by omega H लिख रहे हैं. That is the cutoff frequency of a low pass filter, omega H. तो ये आ गया, इसको हम A नॉट लिख रहे हैं ऊपर न्यूमरेटर को, and this is 1 plus J omega by omega H. If omega is what is omega H? Omega H is 1 by RC and omega H is 2 pi FH. So FH is 1 by 2 pi RC. Okay. Now when F is very much less than FH, what will happen when F is very much less than FH? हम ये term neglect कर सकते हैं. Right? Very small value, when F is very small value, compared, we can neglect this term. So we have only 1 plus RF upon R1, that is A naught. When F is much higher than FH, that time we can neglect one constant value. You have JFH upon FH. That means it is inversely proportional to frequency. जैसे frequency increase हो रहा है, F decrease हो रहा है, gain decrease हो रहा है. Am I audible? Am I audible?
Yes, ma'am.
Okay. Yeah. So we can see that there is an inverse relation with frequency. That means when frequency is increasing, gain is decreasing. Then one thing is left is what happens when F equals to FH. When F equals to FH, we are getting the gain as 1 by root 2 times of A naught. And that is called as 3 dB frequency. Why 3 dB frequency? Because that means that gain is 3 dB down from the, अगर इसको हम dB में निकालते हैं, 20 log VO by VI equals to 20 log of A naught plus 20 log of 1 by root 2. तो यहाँ पे क्या हो गया कि ये 20 log A naught तो गेन A naught है, ये टर्म आता है ना वो -3 dB आता है, अभी देखा था हमने. तो दिस इज, अगर dB में लिखेंगे, दिस इज ऑल्सो इन dB, तो VO by VI इन dB is equals to A minus 3 dB at F equals to FH. Just a second, huh? Hello? हाँ हाँ, DAC का कंबाइन कर लो रिजल्ट. हाँ हाँ. मेरा लेक्चर चल रहा है, ज़्यादा टाइम लगेगा तो बाद में बात करूँ. मेरा 10 मिनट की बात है. Yes. So VO by VI at cutoff frequency is 3 dB down the maximum gain, that is A. तभी उसको 3 dB frequency बोलते हैं. आया समझ में? And use your calculator to find 20 log of 1 by root 2. You will get it as minus 3.01 something.
Ma'am, means practical. Ideally, the gain is A. So practically, we are
Ideally
getting
the gain is A. Also at the lower frequency the gain is A. At F equals to FH, it will be 3 dB down. ऐसा नहीं है कि 0 पे भी तुमको 3 dB डाउन मिलेगा. देखो ना, ऐसा है, ये देखो डायग्राम ऐसा जाता है. ये तुम्हारा A है और यहाँ पे कहीं जाके तुम्हारा A by root 2 होता है, कम हो रहा है. दिस इज A. वो प्रैक्टिकल वैल्यू जो तुमको लैब में मिल रहा है वो तुम कैलकुलेटेड एंड प्रैक्टिकल, दैट इज डिफरेंट. बट हम जब लो पास फिल्टर की बात कर रहे हैं तो जो भी तुमको ये गेन मिल रहा है, इवन प्रैक्टिकल में तुमको अगर ये गेन मिल रहा है तो यहाँ पे FH पे तुमको 1 √2 टाइम्स ऑफ A मिलेगा. Got it?
Yeah, ma'am. Yeah.
और ये हमने जनरल स्केल पे लिखा. If I write in dB, this is same as like this. A by root 2. अगर dB में लिखेंगे तो A dB and this is A minus 3 dB. Is it clear?
Yes, ma'am.
Also we have seen that this is a single first order filter. तो इसका जो स्लोप होगा वो होगा -20 dB per decade. मैंने रोल ऑफ पढ़ाया ना तुमको रोल ऑफ. तो अगर डिग्री of the filter, the order of the filter is 1, so slope will be -20 dB per decade. If slope is 2, sorry, if the order is 2, the slope will be -40 dB per decade. Any doubts?